Trust the auto router shirt.
Trust the auto router. Auto router knows best. Yeah. No, I mean anything of that scale when we're at Tesla, or for that matter, Lilium would have a shirt for it for sure. You got to have the company merch. Oh, absolutely. You know, you get the Battery Day shirts or the like Made on Earth by Humans or you know any program.
Yeah, I saw that on the boards in some of the teardowns.
Yeah, awesome.
I like that little logo.
I feel like when you're at Tesla or SpaceX, it's really easy to make a cool shirt about what you're doing.
Because Elon's already told everyone.
Yeah, like let's say you made sort of a holy grail, one of the many holy grails in electronics as code. You could convert a data sheet into a perfect electronics as code representation. What would your shirt be? You know?
Well, we did that one.
You did this.
Yeah. Well, I mean, the AI did it for us. Right?
A perfect representation, though.
I mean, it nailed the pin list. And given like a kind of grainy photo of the package, it got like most of it right.
It's really.
So yeah. I was playing with conversions of graphs out of PDFs into something useful the other day. I was like, well, how do you want to represent this graph in the beginning? And it's actually like it's kind of hard. Like what kind of curve do you use to model it? It needs to be something efficient. You need to ideally only have a couple of coefficients so you can model it. And so you're just like, okay, so question one is like, here's a screenshot from a PDF, ChatGPT 4.0 mini. Okay, what kind of curve is this out of this list? Okay, you would use a polynomial with two coefficients. Okay, fantastic. Now grab me some data points for that. And no worries, the data point's all correct. And you just feed that in and you can fit a polynomial to it.
Yeah. And I tried that earlier with 3.5.
They've got better.
They did real bad.
Yeah, it's incredible how much better they're getting. I took a photo of a sticky note the other day for one of the positions we're hiring for that had my shitty handwriting all scribbled on it, like sort of a box in the center. It looked like a mind map of the role title, and then just random project notes of like cell sim or something just scrawled all over it. And it made a pretty articulate job description for it as well, actually. So it's really getting incredible.
Yeah. Just yesterday, I'm gonna spoil when we recorded this, but just yesterday, the new Llama was released, 3.1, 400 billion parameters, and it's really good at some things, not amazing at coding. Sonnet still beats it, last I heard anyway. Maybe it needs to be tuned a little bit, but it's really good at a bunch more things, especially in the image kind of spatial area. So it might be worth running some new tests on data sheets. I guess, like, what do you guys think? And I don't know how long we want to spend on it, but what do you think, like, state of the art right now for data sheets is? I guess, like, data sheets have a bunch of components, but, like, those graphs that kind of tell you like the temperature and when properties start to change, I don't think, is it able to get those things out reliably, and the footprint landing patterns and stuff like that? Like, what's state of the art as of today? I think it's mainly just pinless.
Pinless is good. It can get the parametric information on the land and which is what I would go with anyway, because there's not one land pattern that you want, right? Your land pattern's based on your factory, based on your material set, based on your environment. They're different land patterns. So the package is the same. So you can pull that parametric information out, use that to then drive the land pattern generation.
Do you vary the landing pattern in JitX, or do you help people vary the landing pattern or set that up?
Yeah.
Very interesting.
Because your input is like package data, right? And then, of course, it's customizable because engineers have preferences. But yeah, then like, what's your solder mask allowance? What's your like all the assembly characteristics? Is this going to space? Then the land pattern is different in ways that usually people have to manage manually. And you have like 6 variations of the same land pattern.
I guess, like, sort of breaking and trying to segment this market out. When do people? I mean, for a satellite, it makes a lot of sense. You would care about these tolerances and getting everything perfect to the factory. But like maybe for a car, it matters slightly less for some circuits, right? Or maybe it matters for everything. I'm wondering what kind of electronics like don't need to worry about the characteristics of the factory too much, and which ones like care a lot. Like, we are going to use one fabricator.
Yeah, I think it's kind of like asking. Same, for chip design, it's like, okay, well, who can only use TSMC? Well, okay, if you're doing something that only they can do, like you're down at the 4 nanometer kind of nodes,
right.
Then you're like, of course you're stuck with them. And then as soon as you open that back up, if you want like a 65 nanometer process, okay, well, you've probably got, probably still less than a dozen,
Gotcha,
but a couple of
gotcha.
candidates, probably less than a half dozen still. But you've got a bunch of candidates all of a sudden. And I think it's the same with PCB design, where, if you're using large packages and all your resistors and caps are 0603, like, I don't think I would worry or even think about the footprints on those boards, sending them off anywhere.
Okay, cool. So basically the rule of thumb is if you use 0603 resistors or something, you're good. Like, go wherever, something like that.
I think it's a matter of degrees, right? Because if you're trying to mass produce that board, you can make it cheaper if you don't do that.
Sure.
Right? If you're just not making very many of something, then these things don't matter so much.
Yeah.
But I think 30% of circuit boards are trashed before they leave the factory.
Really? So that means the yield is like, so you're getting 70% yield. Is that right?
Yeah, I mean, obviously it increases as things mature, right? As you don't make stupid mistakes in the early revs. But like, you have one of the dirtiest waste streams on the planet. People think they don't need to check these things, and then they end up mattering.
Wow.
Right. So as you think about ramping production, if you go to like 1 device to 10 to 100 to 10,000, you're changing your design. You have production variations. I think a certain commercial product got up through like revision H, which is a lot of variation. So you're spending like all this money, all this time making tens of thousands of bad boards to find yield issues.
Yeah, huh.
So I don't know, our approach to automation is like, if you're going to do something automatically, try to pick the best thing so you don't have to worry about that.
Yeah.
Right?
So
you don't have to consider, you don't have to argue for like, no, that doesn't matter here. It's like, it's just a shape. Just like put down the right shape.
So it's not just about the circuit you're building. It's also at what scale you're building it. And like, maybe you don't care about 50% yield if it's prototypes and you can just kind of, all right, like whatever, we'll order 5 every time and one of them will work.
I will be very upset if anyone gives me 50% yields in my prototype, mainly because I'll be spending so much time trying to bring them up. But yeah, those numbers are pretty bad. I mean, mass production, I'd consider anything lower than like a 3% fail rate is pretty nasty.
Exactly. But like, what's the path to get there?
Yeah. No, for sure. Well, typically, again, depending on which company you're talking about, they might just sell stuff regardless or rework it, which still does happen a little bit these days, although much less so.
Yeah, I think the original Apple Watch was around 70%.
Whoa.
Yeah, they pushed a lot of stuff. They've like pushed a bunch of manufacturing processes, like not very mature, and they're like, got to sell the watches. So they just kind of ate it.
Do you know why? Like, was it like it must have
Fixable
been
and predictable issues. If
Really?
you've been rigorous and had all the time in the world and didn't have to make like a commercial schedule. Like,
It's-
Christmas doesn't move, I think is the phrase.
Yep, that's
Is that
right.
what they
that's
say
right.
Yeah.
down in Cupertino?
Yeah, I think for any in the consumer electronics.
Oh, okay.
Right.
So it's starting to click with me why people talk about physics simulation and all these things so much. Like, because sometimes you won't know until you've already started a really big run or something that you're going to have a really bad yield. And so as much as you can simulate or as many older patterns you can reuse so you know that they work, that's a good thing.
Yeah, or expert attention is often the commodity. It's really hard to get the people that know exactly what problems you need to look at. Right.
Yeah.
There's
yeah.
not, you can make a list of their names and there's like 5.
So there's some opportunity there, especially for electronics as code, because I guess one of the, I think Matt and I have talked about this, but there's not really an intermediary format. You're either looking at the image of a schematic or I guess that's it as input to an AI. But if you have like a slightly better thing, maybe you can build experts and then these experts can kind of review these circuits. I think this is also maybe a premise Diode.run was going for. Like, we'll review schematics and be able to help.
Yeah. No, that was a value proposition we were selling on before building the physical automation. It's like more correct, right? Because you can actually write code to verify your design.
Yep.
Instead of reading it.
Okay, super interesting. All right, I picked a topic, history of EDA tools, not in ordered history, but just a history of, I think, things people would probably recognize to things that are kind of old or people wouldn't recognize.
Okay, in that rough order.
And looking for impressions, compliments, memories, anything to that effect. So the first one I wanted to start with was KiCad, and I think that's how you say it, KiCad, not KiCad.
Yeah.
I didn't know this, but KiCad was actually named after the creator Jean-Pierre he had a friend named Kai, and then he just added CAD at the end of it. So I guess that's where KiCad
for his friend.
Yeah. I think I pulled that from the About page. So it was developed in 1992, became open source in 2013. So like 10 years later, 20 years later. Wow. Huh. And CERN got involved with it. It's changed a lot over the past 10 years. The first time I used it was probably 10 years ago. Yeah. My impression is it's pretty good now and probably going to be the dominant tool for open source hardware development in the near term, while people are still very used to drag and drop tools, especially with Eagle kind of getting deprecated, which is something we'll talk about later. But I'm very curious about your guys' impression about KiCad.
Oh, I'd absolutely agree on the acceleration of its quality. You know, it's like in 2013 when CERN joined, it was buggy, crashed a lot, low on functionality, and I guess someone there really saw the vision of like what it means to have like good quality open source tools, you know? And because since like KiCad 8 is like, I mean, it's still like an open source traditional drag and drop EDA tool, but it's a pretty decent one, you know, by my standards.
Do you ever get frustrated with anything with it, right? Well, like, because when you were at Tesla, at least you were adjacent to the EDA tools that, you know, have the fancy features that Duncan was mentioning, like, I guess, like data impedance matching or something like that. KiCad probably has that by now.
KiCad has the basics. I think the way I see KiCad is it's very well geared for its let's say historical and perhaps current audience. Of it's great to design a hobby project, and if you're going to make tens or hundreds of something, like kind of low volume, it perfectly adequate, does everything you need to. And I think the places where it's lacking are when you get up in the higher volumes. It becomes a little bit harder to manage.
So that's kind of the breaking point for KiCad, is like you start going into volume, maybe you need the pad variation that Duncan had mentioned or something like that. What do you make of that, Duncan? When do you think KiCad breaks down, or what was your first experience with KiCad either?
So I like KiCad a lot. So JitX exports CAD files, and we started with KiCad because it's open source. It has a format, you can kind of read it. Format internals are crazy. Like they had 4 coordinate systems, and one of them was left-handed instead of right-handed. We've all dealt with CAD formats. But I thought it was a fantastic product. So when we generated it, we skipped the part that people usually complain about, which is like library management, and they don't like the way they do component models and something about the schematic. It's like we just write all that data out. And then before we were fully automated, we used the layout tool to finish the design. And I did some wild stuff in there. And the fact that it was open source and you could script it made it really, really powerful. So I did this layout for a test chip at 2,500 pins on a 0.3 millimeter pitch, irregularly spaced as well. So I did this like really fancy like inverted pyramid microvia stacking. And I just wrote a script to do that in an afternoon instead of spending what would have taken a human designer like weeks of just putting vias in. Do. So it had like a layout tool that could represent all that, and is also open source and scriptable, so you could do some really, really powerful stuff with it. Not out of the box and clicky version, but I think it has a lot going for it. And I think the developers are really, really good too. So they have really great product sense. The velocity has been really impressive.
Have you spoken with the KiCad developers?
Some,
yeah. Who works on it now? Are they all over the world? I'm super curious. I haven't thought about this.
I think there's still a lot of Europeans from what I've seen at their GitLab, but I'm sure there's plenty in the US who are balking at me. But
yeah, there are. Yeah,
very interesting. Yeah, let's see. Do you guys? So about that breakdown point, right? And KiCad's competitiveness with commercial tools. Where do you, so breaks down in board quantity? Like, what's the specific thing where people are like, all right, I'm done with this?
I think it's probably the death by 1,000 cuts that Duncan was again talking about before with the memory buses, right? Where if you're kind of expecting it to have some tool to help handle some type of design rule check or some kind of really niche impedance matching or export in some format that you really care about. Like it doesn't have the clicky versions of those things. And so, or it doesn't yet. And Altium has, after having built a tool a couple of decades ago, kind of just extended that type of functionality to where everyone just sort of expects to have that as a clicking tool. And so will it ever get to somewhere of commercial viability? Well, absolutely. It already is for a lot of things. You could absolutely design commercial products, and people do in KiCad. But will companies see enough of a cost saving or productivity jump across from a current tool to a pretty analogous existing tool?
Right.
I think that's really the poignant question there.
Yeah, it's a very high bar.
Yeah.
We had to build a lot of automation to make that.
I know, you keep scaring me every time you mention it.
It's hard.
Yeah.
I'm curious if you guys so Autopile and TS Circuit are permissively licensed open source.
Yep.
KiCad is a GPL. Do you guys think that GPL has held back KiCad in any way? Because like the script, Duncan built, for example, it could be integrated, but maybe companies want to develop that and like integrate it, but like maybe they want to share it, but they don't want to have some of that license involved or something like that.
I think KiCad's feature velocity has been crushing almost every other CAD tools. So if they're being held back, like, I'm not sure what that looks like.
I see. So KiCad's just going to keep getting better and might even be the dominant drag and drop tool. Is that right?
Maybe so. Like what they've been able to build on the time scale that they've built it on, I think it's built like they beat everybody in terms of rate of progress, at least from what I've seen.
What's like, is there anything recently that they came out with that like comes to mind?
Well, 6 was great because they fixed a bunch of stuff internally that was like such a pain. They really did a nice refactor. I think their layout tool is like really strong. I haven't used their schematic tool very much because I think drawing schematics is crazy as a way to design things. So I just don't touch that part. Apparently, there's been a lot. Like I see videos summing up the new features and they're all about the schematics. Like, glad that works for you. I have no context for this.
Yep.
But yeah, like even on the layout side, if you look at the way tools are discussed online, of like what is the experience of someone else in a different tool and their feature velocity. Like I asked this question about people, it's like, have they added any features you use a lot or really care about? And they're like, no. And I asked like in the past 15 years, and they're like, no. I kind of like the way it does my like Gerber export, but that's it.
Yeah.
But compare that to KiCad, right? So if they're being held back by being GPL'd, which I don't think is the case, like it's a real beast in there.
Yeah. Makes sense to me. Matt, any thoughts?
Look, when you say held back, it has to be compared to like this magical imagined future in which they could potentially go faster. And so like, could I imagine a future in which they go quicker, or a parallel universe in which they go faster because they're not GPL licensed? I would say I would actually be a contrarian on this one with Duncan. I think yes, and that's primarily just through observations with other tools and projects and their licensing. And typically what I've seen in the like kind of contemporary open source software era is that these GPL licensed projects, whether it's correlation or causation, don't typically seem to go as fast as their more permissively licensed counterparts. And so only through the power of assumptions, kind of need to assume that if KiCad were more permissively licensed, for whatever magical reason seemed to apply to everyone else, it would probably apply to them as well. But it's getting more people on board, a different groups maybe potentially injecting funding or just upstreaming changes of their commercial variants of it or something.
Yeah, I think people underestimate the power of rage.
Yep.
You know, when somebody forks your project and rebrands it and then adds one feature, right? Then you're like, oh hell no, and you might go crazy, right? And you see this with MIT projects all the time, or Apache 2 projects, where somebody forks it, they call it a new library. I think this kind of happened with Redis, right? And then 3 Redis things sprang up when they changed licensing. So like, people are just, I don't think it works for everything though. I think like you can also get a situation where you have people scattered all over the place and there's no dominant tool because anybody can kind of fork it, and then all of a sudden there's no unification. So KiCad has had the effect where like, okay, what else? Like another drag and drop tool? Like You guys know one? Another open source drag and drop. There's nothing. KiCad is the big player.
Oh, it's absolutely the big player. I wonder as well if there's, my analog is, I guess, primarily looking at software modules, libraries, because that is what the bulk of the software I touch is. But, you compare that to other large projects. Well, okay, what's something of at least somewhat analogous scale to KiCad that has an MIT license, for example? Like
Right.
Octave comes to mind, but no, it's GPLv.
Oh, interesting.
I can't remember which license.
Octave is like MATLAB, but open source.
Open source MATLAB, exactly. And then you obviously look at something like Linux itself and all the surrounding tools and periphery, and actually, it's typically, very frequently GPLv2 licensed. Some BSD license as well, of course, out of things. But
lesser GPL also around.
Yeah. And so maybe it's just a case of with these bigger kind of almost a little more monolithic projects, it makes sense to take that less permissive route.
Yeah, it's something I'm really curious about, because when I picked MIT, I was like, you kind of get this paranoid feeling, and you probably feel this too with Apache too. You get this paranoid feeling, like what will happen. Speaking of licensing, which is the most interesting topic ever, I'm sure to everyone. I saw JitX was doing something with the CERN hardware license, which I had never heard of. But maybe I'm wrong.
So they have an open hardware license.
Yes.
So for the free tier, it's meant for people that want to share their work. Right? So you're going to try JitX, like absolutely don't have to talk to us. You can just try it, but your designs are open source.
Nice.
So that's kind of our split for moving to the paid tier. Yeah, I mean, CERN does a lot. Like it's part of their charter to disseminate knowledge.
Right.
Right. So they believe a lot in like taking the technology they figure out, because they do some crazy stuff, right? Like regulating 10,000 amps at like on a 50 millisecond time little pulse.
Yeah.
And then disseminating that back to the member countries. Right.
Yeah.
So they thought a lot about how to do that.
So they're basically, like I think there's this organization OSI that like kind of ratifies open source licenses, and I don't think I'm probably wrong about this, but I don't think there's an equivalent in the hardware lens. CERN would be sort of the equivalent of OSI for hardware, maybe, or maybe OSI does cover hardware.
Open source hardware OSHW, I think, is the
that's right
organization.
Yeah. So maybe they have some licensing. Well, I went in deep
the
on an
lawyers
area
involved,
I don't know about. Yeah, exactly, right?
Yeah, nothing more interesting than context.
Yeah, nothing more interesting than context. Might have to edit around a little bit of that.
Well, I thought while talking about licenses you rolled into there, I assumed you were going to bring up Eagle and how it's significantly changed under the ownership of Autodesk.
That's right. So Eagle was acquired in 2016. And then 1 year later, Autodesk decided it would move towards a subscription model. And I think it's kind of rolled into Fusion 360 Electronics. It basically is Fusion 360 Electronics. So it's going to be kind of part of that program. For what it's worth, Fusion 360 is pretty popular for doing mechanical design. It might be one of the big solutions for hobbyists if they don't want to. Yeah, actually, I'm not sure.
For hobbyist period, at least for a long time there, I'd say it was definitely the de facto for hobbyists, with Onshape now sort of encroaching a little bit, and FreeCAD definitely improving in its capacity.
Right. And Fusion 360 is also, they do something where they have like a fairly cheap license for startups for 3 years or something like that. So I think it captures a lot of people who are just getting started. 3 years is like the right amount of time, right? Like you're either making money in that time or... So yeah, what were your guys' impressions of Eagle? Did you guys ever use Eagle?
Yeah, so I learned on Eagle. When we were testing these ideas at Berkeley, we actually wrote an Eagle exporter first.
Oh, nice.
They used to have like an open XML format before it was like made it proprietary, right?
Eagle might be my favorite file format, because I'm sure you guys are in the same boat. You've probably had to write a lot of parsers at this point, and it's just kind of XML that's fairly easy to read, and things are named pretty reasonably.
Yeah, I mean, KiCad's on S expressions, which is also pretty straightforward. Yeah, but later moved to KiCad. And been happy about
what was the what triggered the move to KiCad from Eagle?
Things like a push and shove router.
Oh, interesting.
Right. Yeah, that's a big deal. Yeah, it's very helpful.
What's a push and shove router for our audience?
So if you do a design in Eagle, you can route a trace and you run a check, and it tells you this trace is too close to this other trace, and then you move it manually, and then you run the check again.
Yeah.
And you're like, and it sucks.
It's no longer too close to this trace. You're like,
Yeah.
oh, thank you.
Good. But it's too close to this other thing, right? So you're like, you have no feedback while you're routing, and you instead run this check, right? That's opposed to like, say an auto route that's like constraints driven and just makes correct geometry,
Right.
without you having to run a check. That's like
Right.
on the other end of things.
And you're sort of okay, very interesting. So, do we know if KiCad 8 has this feature? Push and shove.
No,
so they
it's been there
introduced it
since like 5 or so.
Sorry, excuse me. So you moved from Eagle to KiCad because it had this feature and Eagle didn't. Yeah, Eagle seemed to kind of stall out a little bit, like really great, and then KiCad did overtake it for sure.
Maybe I'll age myself a little with this one, but I mean, like getting into electronics for me, Adafruit and SparkFun were really on their up at that
Right.
era.
Yeah, same.
And it's, you know, they were fantastic, loved them. And because they used Eagle was the only reason I ever touched the thing. And then they integrated into Fusion 360. I did a flex PCB in that for a touch probe for a CNC machine.
Yeah.
And I was like, cool, I can like wrap my circuits around stuff. Like awesome, fantastic, and kind of, you know, sort of Fusion. Fusion's got a little clunkier these days, so it's less enjoyable for me to use. And when you have an already less enjoyable CAD package kind of being a little walked on by an open source, completely free alternative,
Yep.
you're almost a bit nuts not to take it, aren't you?
Yeah. Yep. Yeah, and I'm not 100% sure about this. We have all somehow none of us use Windows, which is probably right. Do you use Windows, Duncan?
I test and document on Windows.
Test and
'Cause most of
document
the customers are on Windows, right?
Right. It seems like Windows is still kind of really popular for drag and drop. I think, it's kind of weird the direction with Fusion 360 because I think that's like also very Windows only, but Eagle kind of runs everywhere. Is that right?
Fusion 360 runs perfectly fine on OS X and maybe Linux as well.
Oh, really?
Yeah.
Okay, so they're doing pretty good.
Thank
Doing
God.
pretty good. Okay.
Yeah.
Very interesting.
It's actually an interesting point. We asked if KiCad would compete with commercial tools. And I mean, definitionally, yes. We've just stated now that it's overtaken Eagle, at least
Yeah.
for us.
Yeah.
I'm curious as to why Adafruit and SparkFun have not begun using it for their designs as well.
I have never seen a KiCad file on a SparkFun or Adafruit page yet.
Not yet.
Yeah, and it might just be because they made a lot of really good stuff, and I think that maybe the fringe of the new stuff they're working on is just kind of different, and I don't look at it. Like they made a bunch of motor controllers, 5-10 years ago. Those are great references. You might not need to remake that, every year. So maybe I'm not looking at the most modern ones. But it seems like they haven't chosen KiCad as a successor yet.
Yeah, interesting one considering their motives around education and whatnot and accessibility.
Right.
So
Right.
we'll have to ask.
Yeah, and ideally, eventually, they have some kind of electronics as code, something else there for people to use as well. But yeah, I'm not sure. Do you think that's a future we might live in, where SparkFun kind of publishes the code and they have a GitHub repo, instead of a bunch of files you download?
Yeah, we talked to, I think, Nate at SparkFun about this, like when we were first starting out. Not much interest there.
Really?
They also tried to make their own tool, like SparkFun a la carte.
Righto.
Discontinued, though.
Oh, really? I pulled it up like last week.
Oh, it's still working. Okay.
Yeah.
Maybe I just couldn't find it. It's like looking for it. Like, where's the tool? I know
Yeah,
it's
it takes you to a different subdomain, so I think that's probably it.
I don't have SparkFun a la carte on my list. Tell me a little bit about SparkFun a la carte since you used it recently.
Well, I wanted to check that it still exists, but I played around with it a little bit. So, I mean, it's kind of a... you can imagine it like IP blocks in Silicon Design, where you click, I want a microcontroller, I want a temperature sensor, and it has two blocks of different size, and they just sort of get mushed into this rectangle. And you can kind of just continuously add to this board in whatever way you want, and it'll assist you in connecting them up to, whatever's I2C or SPI buses for you, that type of thing. Order out the board and, I think they can make certain guarantees about the board, but I have a cheeky hunch that there's actually a human in behind the whole process, given the first batch cost versus continuing batch costs for it.
Oh, interesting.
Which I think it was $900 to do a custom simple board from the get-go and then continue from there.
Very interesting. It's almost like, that seems out of range for hobbyists. So... yeah, it's a little weird when the open source solution requires paying money. Even if something's open source, if you have to pay a bunch of money, it's like,
I think it was very similar to Geppetto. If you ever tried Geppetto,
I've heard of it, but I've never run it myself.
So Geppetto is a tool from Gumsticks, which they made Linux single board computers. But yeah, exactly the same thing. Like kind of higher setup costs. They could do a bit more complexity. but then Altium bought them and then rolled them into Upverter. So it's the same sort of like block.
Oh, yeah. Upverter falls into this category as well of
it does
sort
now,
of,
right?
Yeah. So you drag these kind of big blocks around and it sort of just figures it out. Upverter wasn't always like that. When I first started using Upverter, it was like kind of just a web version of Eagle. I thought, I don't know, I was doing footprints. My favorite feature of Upverter was you could route PCBs collaboratively, which is a feature that I don't know how many EDA tools have, but it seems very, very uncommon.
No,
maybe
got that one.
Who has that now?
JitX has that.
JitX has that, yeah.
If you want it. I mean, you're driving
You pay extra for that one?
So. No. You just have to, we don't do the hosting for you, so you got to expose your own.
Right out. Do people run a JitX server?
It is a server.
Oh, gotcha.
Right, so it runs locally, and then you can just put a front end anywhere you have Chrome, right?
Yeah. We're so different than all these other tools. Almost.
Oh, we recently added like multiple views as well, so I can have like 6 views of the same board up and be like.
Oh, that's awesome. Yeah. When I'm in an AI co-working space, that's where the studio is. When people walk by my computer, they're like, oh man, that guy must be deep tech because I have a PCB up. And I'm like, no. I'm sorry. But anyway, all these windows would be very good for further convincing them I'm the deepest tech company.
He just keeps bringing people in for interviews. Wow, that's incredible. So knowledgeable, well connected.
Oh my goodness. So the tool I've probably used the most is called DipTrace. I don't know if you guys have ever used
literally
this.
never even heard of it.
I've seen it. It looks pretty good. It has some nice layout features, I know.
DipTrace to me feels like a paid Eagle, but it's just like so straightforward. You know what I mean? Yeah, it's so I think now KiCad is so competitive. I don't know that I would reach for DipTrace or pay for another license. By the way, these one-time licenses, they're really not one-time licenses because every time I change companies or whatever, I pay again. So it really feels like maybe a bi-yearly subscrition or whatever, or I buy it for somebody else, right?
Depending on your mobility.
Yeah, depending how frequently you change jobs. Yeah,
right. The real trick when you're selling a one-time payment EDA tool is sell it to people who are likely to be fired because they'll keep carrying it to each company they go to.
Assuming they love it and it wasn't the reason they got fired.
Right.
Which, now a big one here. I assume you've heard of this one, Altium?
Altium. Actually, I haven't. What is Altium, Matt? But break this down for me.
Well, its origins trace back to Protel, but it was
AutoTrax before that, right?
I wasn't around back then actually, but it was. And fun fact, founded in Tasmania, Australia. It's an Australian company.
Nice.
Still on the ASX, the Australian stock market. Mm-hmm. Although now, just recently,
Until September, right?
What? Sorry.
Until September.
Because Renesas purchased it.
Which
is an interesting one actually. Do you know if they have any other EDA tools at Renesas?
Yeah, they've got a pretty good stack.
Okay. Yeah. Which ones?
I think they skew more on the developer side of things.
The software side.
Yeah.
Yeah, makes sense.
And given bridging into FPGA, I think.
Yeah.
So it's in between. Yeah. There's place and route in there.
Because it's an interesting company. I mean, Altium is ubiquitous in the industry. It's the most used by a decent margin by just sort of number of seats, number of designers that I've seen.
Right.
By a pretty significant margin. And not just the ones in Australia, I do have to say. But it's not by revenue, total revenue. Cadence beats them out there, Cadence Allegro. Mm. You think my statistics are incorrect here?
I think what is their installed user base? It's like 100,000.
I think it's about 100,000. I think.
Yeah.
I thought it was about double that, but
200,000.
So we'll see where they're
seats granted, not
so seats,
not users.
Right. Yeah, I mean, but like when Autodesk acquired Eagle, they were at 2 million.
Whoa, really?
Yeah.
2 million users.
Yeah. 2 million like installs of Eagle. Like they bought. Why do you buy Eagle? They bought it for the user base.
But Eagle does have that free tier. Is that?
So you have a free tier. So like maybe we're distinguishing between paid versus free, and then like paid installation seats.
I wonder where the circuit maker from Altium gets in there as well, because we're talking about their commercial offerings, of course, with their seat basis.
Right. Is circuit maker like another Upverter, or what? Where does that fall? Okay.
Yeah, it was like another design tool, and they bought it, and they kind of like parked it in the free spot to make it harder for startups.
Gotcha. You know, earlier we said we were talking about open source tools. We talked about KiCad and being the only dominant player. I think I forgot about fritzing. You guys know fritzing, since high-level tools kind of count, I guess. Have you guys used this?
I thought, didn't they make breadboard wire jumper kind of diagrams?
I think I think that was like the main thing.
Okay.
But I think they do SMT now. I could be wrong.
Okay.
Interesting.
I might need to fact check this.
Well,
And there's a bunch that aren't on the list, but yeah, fritzing, you had Patcher, you had Breadware, you had Metamorph. There's all sorts. There's been a lot of startups in this space.
yeah.
This is a big graveyard.
I know.
Big graveyard, a lot of skeletons.
Duncan is, for the listeners, has been around the block a little bit longer than Matt and I. So, you know, he sees the graveyard. We see the clouds. We only see the future.
We have to. We got to look up.
We just got to look up, ignore the ground. Yeah. I think an interesting thing, since we're talking about commercial tools, I think almost everything we talked about so far has been free, but Altium, I looked this up, is somewhere around $4,000 a year per seat. So that's kind of where it starts. There are lots of discounts
Discounts
that you can get.
sales.
There are also,
everything.
there's also much higher amounts you'll pay.
Yeah.
How do they get people to upsell? I don't actually know. Like, do they have like a plugin or some kind of feature that you're like, oh, I need this, even though I paid $4,000, I want something else?
Oh, absolutely. There's all sorts of additional kind of modules of tools and checks and stuff you can kind of pre-integrate. And they also host servers for your they also provide some servers like the Nexus server for component management on an organizational scale, and all sorts of review tools that you can run in the cloud. I'm not sure you actually need to pay extra for those anymore. So extensions in terms of functionality and modules you can kind of bring in preemptively with design tools.
Very interesting. Your phone completely overheated, I think.
Oh, fantastic. Okay.
It's off now. GoPro running. Nope. We lost the video. Damn.
Is Duncan still going?
Duncan's good.
You want to scooch into the frame?
Yeah, I'll jump on it.
I wonder if I can get this guy to roll. We'll cut all.
What is it? Is it just died?
I don't know.
Yeah. Well, that's sub-ideal.
I'll roll this again. Let's see. Can we get this guy? This guy's going again. I don't know why it turned off, but new shot.
We just,
probably
won't
wrap it
cut,
up soon.
we just won't cut to me for a while. Yeah, we've been going for a long time. So look, we're really at the two big players in the market here, the relevant players on a commercial scale, Altium and finally Cadence here.
Yeah.
Now,
Mentor Graphics, I see as well.
yes, I do see them. I've heard of them plenty enough. I've never actually really seen companies using them for particularly much. Have you got some big companies? Well, actually, and Zucker's missing off this list, which Bosch at the very least uses.
Yeah, Zucker is also big.
Zukin?
Zukin.
sorry.
Yes, excuse me.
Yeah. Well, I think aerospace, you'll see a lot of Mentor Graphics.
Oh, okay,
Right?
interesting.
So, like, I think they did the Starlink terminal in Mentor Graphics
Oh.
because the amount of vias crashed Altium. Right? So you get these enterprise tools where you need to deal with more complex designs that just cause tools not meant for that to just explode.
Yeah.
Mental Graphics, they've got a good. Am I remembering correctly? They have good harnessing design tools as well.
Capital Harness, I think, is also owned by Mentor Graphics.
Okay. Oh, there you go.
Which is owned by Siemens. Right.
This is where we're like way out of my knowledge zone. So Cadence, what's the distinguishing feature here? They have a bunch of products too. I feel like it is enterprise. You're doing something really difficult, you might go to Cadence. It sounds like Mentor Graphics, the characteristic is aerospace. I'm not, is that right?
That's usually where I see it.
Yeah.
Also, like instrumentation, there's packaging, there's a variety of things. So, yeah, like aerospace and defense systems. It really depends on the company and their lineage, right?
So it's primarily a historical thing then?
Yeah, I mean, we've had a customer and they were on a tool, let's say, and they switched every 20 years or so. Like, they don't switch faster than that. Like I said, the enterprise scale.
This is a pattern. There's enough 20-year periods where this is a pattern.
Yeah.
Well, you need to have everyone who remembered how bad the last tool was,
Right,
and the
right.
last transition was leave the company
It's
before.
literally generational.
Yeah. But and you can look at Cadence, it's like they'll publish their 10K, and it's like, well, our average deal cycle is 18 months.
Right.
So it's sold with like salespeople that are like really good at golf and they're like engaging with the VPs and then it is then trickled down to the designers.
Right. Huh. Okay, I want to touch on something that I don't think people usually talk about, which is Easy EDA, which is easily the newest. Wait, this actually says it was launched in 2012. But what was interesting about Easy, are you guys familiar with Easy EDA?
Yeah.
It's created by JLC PCB. It's an online web tool, so another player in the web tool space like Flux. It was really big at open source, surprisingly, at that hardware conference. Yeah, I kept hearing about people doing Easy EDA. And
were you standing next to the JLC PCB booth?
Oh, of course. I mean, they're all over it. Yeah, JLC PCB is a big sponsor of that conference, I think, and a couple other PCBWay as well. But it's very interesting. I guess like hobbyists, maybe building the circuit. There's got to be like some ratio between how hard it is to actually manufacture and how hard it is to design. And it must have shifted a little bit towards, wow, it's really annoying to manufacture in any other way to get this fully assembled circuit board for people to use Easy EDA because it's kind of unproven. You know, like we were saying earlier, SparkFun and Adafruit have all of their schematics in Eagle. So you would think you would do something familiar or at least this kind of popular KiCad solution. So kind of I mean, I don't know. What do you think? Why is this thing popping off if it is?
So I think the thing that makes it unique is they have that really tight connection to the factory.
Yep.
You know, like Geppetto used to have, or Smartphone a la carte has. So you don't have any fear that if you put something on a board there, they won't be able to make it. Because
Right.
of all of this like factory validated design data, which as like someone new to design is like a big source of uncertainty. Like, so a lot of our product design is like, well, how do you drive fear out of the design process? And I think EDA knocks it out of the park on like factory validated design data.
Right. And you're also pulling in the footprints right from the factory. Mm-hmm. And so you kind of have their preferences, although I'm not 100% sure how the accuracy on these things are. I haven't made enough boards with JLC to know for sure, but I mean, it seems to work for a lot of people.
I'm yet to run into any problems personally. This is probably as far as I can personally say.
Okay, so that's Easy EDA. Flux AI, honorable mention. We've mentioned them a couple times. I haven't used them for a real board yet. I don't know if you guys have Flux.
I've never made it to the end
tool.
of a board design with them.
Yeah, same. I keep trying.
Yeah. They're improving. They're definitely improving and doing a lot of interesting things. It's a great team. But there's like every time I go to do something in Flux, I kind of just end up only really wanting to start the things in Flux that I don't.
Yeah.
Like, oh, it seems fun to design or something. Like, I don't really need this.
Right.
But I do know that they're taking off at least reasonably well with people who are kind of just sick of whatever ingrained tool is stuck at their company.
Yeah.
And I think that kind of ease of entry is something that's really going for them there.
Yeah, definitely. Did you get to use any of these sort of AI features? We were talking about AI and how electronics as code is really great for AI, but you know, there are a couple people, SnapMagic 2, kind of pushing the AI side on the more, in a more visual way, I guess. I don't know exactly how their magic works, but did you guys get a chance to try it? I'm not sure.
It sounds like I'd put them in the same bucket as CircuitMind as well, where you have sort of like high-level block diagrams and then it's kind of stitched together with AI. So you have like a visual programming language, right? Because block diagrams are a programming language. They're just not a very good one.
Right.
But then you can like add some AI to it and then it kind of handles the bad parts of that.
Fair enough.
I haven't tried it myself. I think they have demos that are public.
Okay. Well, listeners, look up those demos. Sorry. Okay, excellent. And we've been an hour and a half. I think that's a pretty good place. Any final thoughts?
Oh, nothing other than to thank Duncan for coming across, having a chat with us. It's good to meet you for third time now, I'd say. And continue running into you at various events around the base. Yeah.
Very cool. Thanks, Duncan. Thanks, Matt. And that's it.
Thanks, guys.
I'll cut somewhere in here. Very cool. Let's see if my camera died too.
Yeah, I wonder. Well.